Okay, so in chemistry, when dealing with compounds, sometimes it's useful to know the percent composition of each element in the compound. But before we get into that, say you have this list. You have 5 blue M&Ms. So these are all M&Ms. 3 orange and 2 green. What percent of your M&Ms are blue? All right. If you're anything like the kids in class when we did this, you will say 50%. Okay, to do that, you find your total M&Ms. 5 plus 3 plus 2 is 10. Okay. And then you do 5 over 10 times 100, and that equals 50%. Okay. If you apply that to the other ones, then you'll find 30% orange and 2% green. When doing percent composition of chemical compounds, the process is very, very similar. So this is a very simple concept. You just, instead of counting M&Ms, have to count mass. So to do percent composition, you must find the mass of each element in the compound and use that to get your total. All right, so first thing, once you know what your compound is you need to calculate your formula mass, or the total mass of everything in there. Then, once you have your total, you're going to take the mass of each individual element, okay, divide by that total, and then lastly, multiply by 100. All right, so let's apply this to a problem. So, calculating your percent composition. In this case, we're going to do magnesium carbonate. Now, before you can even start the steps that I just showed you, you need to know what your compound is. So you do need to be able to convert magnesium carbonate into a formula. Okay, so magnesium is Mg, and carbonate is CO3. Now, carbonate is on your polyatomic ion chart, which should be a huge indicator that we're dealing with an ionic compound, not to mention magnesium being a metal. So magnesium is 2 plus, carbonate is 2 minus, so we are dealing with MgCO3. So our first step is to find the molar mass, the total mass of magnesium carbonate. So if you do that, you're going to have 1 Mg, 1 carbon, and 3 oxygens. All right? So now that we have our total mass, the 84.32, we're going to find the percent of each different element. So for magnesium, you do the 24.31 divided by the total mass times 100, and you get 28.83%. For carbon, you take the 12.01 and divide by the 84.32, multiply by 100, and you get 14%. And the last one with the oxygen, this is the one where a question may come up. You still need to include all of the oxygen, so 3 times 16. So oxygen would be 48 over 84.3 times 100, and that's going to equal 56.93%. Okay. One last thing that's always a good idea to double check and make sure you didn't make a stupid error somewhere, like only counting 1 oxygen, is your total should always add up. Okay. So you try this one. So pause the video for a second, try this one out. Hint to you, magnesium is still plus 2. Chlorine, however, is minus 1. So make sure you form your compound right. But if you set up your formula right as MgCl2, all right, you'd include 24.31 grams for magnesium and 35.45 times 2 for chlorine. And then you get 25.5% of magnesium and 75.5% or 74.5% of chlorine. And again, it adds up to 100. Okay. The only exception to this 100 rule is every once in a while you might find that it's 100.01 or 99.99 or something like that. That's probably coming from just differences in rounding. If you always go to 2 decimal points, it's less likely to happen. Okay? But if you're getting things like all of a sudden it's 92%, we probably forgot something. Or if you're getting 130%, maybe we doubled something. Okay? So, just keep an eye out for that and see you in class.